There we go. All right, so when we do this, figuring out whether we have low outliers or high outliers, small outliers or large outliers, this is called the 1.5 times Iqr rule. What'd you say? That is a very boring name. However, it does help you remember what the rule is. I have gotten the question before of why is it 1.5? The guy that came up with this, he was a statistician and was trying to find a way of quantifying or talking about things that were outliers. And his reasoning for this was that 1 times the IQR felt too close and 2 times the IQR felt too far away. Like he felt like some things were outliers and they weren't quite 2 interquartile ranges away. So that's why it's 1.5. He just kind of split the difference there. When we have outliers, there are often times that you will see that represented on the box plot. So now that we've done this work and we see that there definitely is an outlier, how many outliers did we have again? Just 1, because we only had 1 data value that was over 1.5 times the IQR added onto Q3. 74 was that upper bound. We had a data value of 77. The way you will see this represented in a box plot, let's see if it'll let me do this now. So what was the data value that was just smaller than that 77? You guys go find that other data value, the one on the dot plot that would have been 1 smaller than 72. We had a value at 72? Okay, I'm trusting you guys on this because I'm not pulling my data up. So if it is not an outlier, the highest value that's not an outlier is where we would put the end of that whisker. And any outliers that we see, like this one at 77, it's still going to go on our box plot, but we're going to use a star to represent any outliers. So we're going to still see the absolute maximum and absolute minimum values that are on there. Any outliers are going to be represented by these little asterisks, these little stars. And only things that are within 1.5 times the IQR away from either Q1 or Q3 would be the ends of my whiskers there. Does that make sense? Okay. I want to make sure, especially when you guys are reading box plots, that you understand what it means when these asterisks are showing up. These are values. They've already been identified as outliers there. All right, last question on this side. Ashmita is 63 inches tall. How does her height compare with the other AP Stat students in her class? So Ashmita was the one that got this data. Head back here. Ashmita was a student in 4th period AP Stats. She recorded the heights of everyone in her class. Here's those values. Her height is 63 inches. How would you talk about that in terms of the group? Is it larger than what is typically expected? Is it lower than what's typically expected? Around the same. Why? Median is 63 inches, absolutely. So Ashmita is the median value. She's taller than how much of her class then? 50%, and she's shorter than 50%, absolutely. So I would say Ashmita is the median value, which would mean she's taller than 50% of her classmates and shorter than the other 50% of her classmates. She is right in the middle. That was all we had to finish up yesterday, other than the backside talking about our important ideas here. So once you guys are done with question number 6, I want you to flip it over on the back. And I want you to look at that important data there, the important ideas. Oh, I don't know why it did that. Let me get it back. There we go. All right, important ideas that we covered here. We had 3 big ideas that we were looking at. How to calculate outliers, we use the 1.5 times IQR rule. A low outlier is going to be any value that is smaller than, less than, Q1 minus, that should be 1.5, not 1.35. Guys, go ahead and scratch out that 3. That's a typo. I don't know how the 3 got in there. Probably a finger slip when I was typing it. Sorry. Low outliers, anything smaller than Q1 minus 1.5 times the IQR. Any high outliers or large outliers, anything that is bigger than Q3 plus 1.5 times the IQR. Our 5-number summary, we can read right off of a box plot. Minimum value is going to be the farthest to the left. Obviously, if there is a low outlier, it would be the farthest to the left, and it would be a star. Otherwise, it's going to be the end of the whisker. The left side of the box, that's your first quartile. In the box, that is your median. Right side of the box, that's your third quartile. And max is going to be farthest to the right. So it's either going to be the end of the whisker, or if there's large outliers, it would be the farthest to the right large outlier for your maximum. When we're comparing distributions, this is SOX. We're going to compare the shapes of those 2 different distributions. We talked about doing that with histograms already. We can compare that with box plots. We can talk about the shape. I remember talking yesterday, we could say that it had a right skew or a left skew based on which whisker is longer. Like, is the box further to one side and there's a really long tail out to the left, then we'd say it's a left skew. If the whisker to the right side is really long and the box is scrunched over on the left, then we would say it has a right skew. If it's pretty much in the middle, then we would say it's a symmetric distribution. Outliers, we can now calculate those. So anytime you guys are given the data, you would absolutely be expected to calculate whether or not there's any outliers there. Obviously, I'm not going to give you a data set so large that you don't have time to calculate that by hand if I'm going to ask you about outliers. Center, how do you decide between the mean or the median? When is mean better? When it's symmetric. When is median better? When it's skewed, or when you have outliers, which would also, in effect, it's going to skew that mean. Variability, this is our spread. We have standard deviation, we have IQR, and we have range. When would we choose to use standard deviation in our descriptions? When it's symmetrical. When we've chosen to use the mean, that's when we're going to talk about the standard deviation. We're doing that because if you guys remember, when we calculated standard deviation by hand, we were using the mean. It was data value minus the mean, whole thing squared, and then we added all those up. So the standard deviation is based on the mean. So if we use the mean to describe our center, we're going to use standard deviation to describe our variability. What about IQR? If there's a skew, or if there's outliers. If there's a skew or outliers, if you would choose the median to describe the center, the same reasons that you would choose median is why you would go with the interquartile range to describe how spread out that data is. Range is also a measure of variability. However, I will tell you that, like, if you have the you have the standard deviation, you have the IQR, and you have the range, depending on what you choose up here, I would choose that. Range usually gets used when you don't have access to standard deviation or the IQR. If you don't have access to that information and the only thing you can really calculate about it is the range, then that's what you would use. But that's kind of your fail-safe at the end if you don't have anything else. Make sure to work context in anywhere and everywhere that you can. What is this a distribution of? Include units on any of your values up here for center and variability. And you need to use comparative language. Can you guys give me some examples of comparative language? More than? Greater than, less than, approximately the same. That would be a comparison. You're looking at those two values. Down at the very bottom, there's two box plots. Mr. Wilcox, huge fan of University of Michigan. Favorite season was 1997 because it was a perfect season. Here's a back-to-back, that's not a stem plot, that is a box plot. It's a back-to-back box plot of the points scored by the 1997 University of Michigan football team and the arch rival Michigan State. It says write a few sentences. That means you're going to have a short paragraph or long, depending on how you do it, but you need to have at least one sentence that talks about shape and or outliers. You can combine those into one sentence. You need a sentence that is comparing the centers. You need a sentence that's comparing the variability. And you need to work context in there along with your comparative language. So write a few sentences, at least 3, that is comparing these two distributions. I'm going to give you guys let's take about 5 minutes to see what you can come up with, and then we'll compare yours to mine. So you're going to have to approximate it, but yeah, you can do it approximately. Oh, thank you.
Yeah, so it's symmetric, right? But we're not giving the mean.
Correct. You're not given the mean. So if you don't have access to that information, you give what you do have.
I should go with the median.
Yes.
Because I don't have.
That's yes. That's exactly what I would do. So I kind of looked at and analyzed these two graphs before I wrote my sentences. One of the things that I noticed about University of Michigan, top and bottom, so from Q1 down to the minimum, from Q3 up to the maximum, those appear to be about the same distance. So it's looking pretty symmetric to me. Lower 25%, there's about the same distance away on that upper 25%. I noticed here on Michigan State that if I look at the top half, so from the median to the maximum, there's a lot more variability there because it's more spread out than there is for the lower 50%. Overall, I did think that both graphs looked approximately symmetric. But again, we've got our median up to our maximum. There's a lot more spread here for that upper half. All right, so what I came up with, and if you don't have as many sentences, not as many sentences, but as many words, but you hit all the big ideas. So the distribution of points scored, there's context, by U of M is roughly symmetric, so I'm describing shape, while, so now I've got some comparative language going on, the distribution of points scored, I'm sticking context in again, by MSU is slightly skewed right. If you said it was approximately symmetric, that would be fine. I went with approximately skewed right just because I was looking at the median to the maximum versus or compared to the median down to the minimum. If I could actually see a histogram of this data, I might say it was slightly skewed. I might call it symmetric. It really just depends on that visual appearance. The centers of both U of M and MSU are the same with medians of, and I would probably put about 25 points. I'm guessing that's what it is. It looks like it's right above it. All right, so centers, obviously I'm hitting that part of SOX. Both, I've got this comparative language, they are the same. MSU has much greater variability, so much greater, I've got that comparative language going on, has much greater variability than U of M, with an IQR of about 22 points. I'm getting that context in there, as opposed to, so here's some more comparative language going on, U of M's IQR of about 9 points. Neither U of M or MSU have any outliers. When we've got that SOX going on off to the side to remember everything we have to hit, there's no reason why you have to describe it in that order. Those are just all the things that you need to make sure to touch on. Perfect. All right, yes. Yes, and for this one, even though those distributions are both approximately symmetric, because all I have is the box plot to go with, all I have access to is the median and the IQR. So even though they're approximately symmetric, and if I had access to all the data, I would use the mean and the standard deviation. I don't have those pieces of information with just a box plot. Does that make sense? Okay. Yes, yes. So that's a really good point. Whenever we have access to actual values, even if we have to kind of approximate it, like it's hard to read off the graph, we still want to be giving those values on those pieces. So when you talk about the center, you're going to state which measure of center you're talking about. Is it the mean or is it the median? and then you're going to provide a value, precise if you've got it, approximate if you don't, and make sure you stick context in there by adding some units on that. Same thing with your variability. Ballpark it if you have to. If you have access to the exact values, use those exact values, stick units in there. Do you guys have any questions for me about this piece? Give me just a real quick thumbs up, middle, down. How are we feeling about using SOCs to describe our distributions? All right. I would say after the first day that we did it, I felt like everybody was right here. So I think this is an improvement, and I saw a couple of these. So I think we're working on it and we're getting better at it. Awesome. Okay, I'm going to put you guys in groups of 3. I will let you pick your own groups. I'm going to have one group of 4, or we could go with 2 groups of 2. So there's either going to be 6 or 7 groups in here. Groups of 3 is the preference. We're going to work on a review activity. You guys are going to practice. It's in your packet, so you can kind of start looking at it. Looking at baseball, Barry Bonds, versus, I don't remember who else they have on here. Mark McGwire. So Barry Bonds, Mark McGwire. So in your groups, you can go ahead and start getting in your groups. I'm going to give each group a type of display. So we talked about histograms, we talked about dot plots, we talked about box plots, and we talked about stem plots, those stem and leaf graphs, distribution. You guys are going to get one of those 4 assigned to your group. That's the visual display you need to make. So you're going to create the display. You're not going to do it on a whiteboard. You're going to do it on a piece of paper, and then we're going to post them around the room so that other groups can kind of see the data display that you came up with. In addition to your display, you need to describe the distribution based on what you've created. So use SOCs for that one distribution. And then on your own paper, for your own kind of thinking through, talk about advantages and disadvantages of the type of display that you were given versus some of the others. So what are some advantages of doing a display of that type? What are some disadvantages of doing a display of that type? All right, I'll give you guys a couple minutes to organize yourselves into groups. Then I'll come around with the paper and access to markers and all that jazz, and I will give you guys what type of display you're going to be making. All right? So again, groups of 3 is ideal. If you want to just be partners, I will allow that. No more than 4 people to a group. So 3 is what we're going for. 2 is the minimum. 4 is the maximum. Let you guys pick your own. All right, so here's your paper for your group. If I could have one person from each of the groups raise their hand, because I want to make sure I'm getting everybody. Okay. You guys are good with 3 or 4? 4, King?
All right.
All right. You guys. Two groups of 4 over here. So guys, I'm going to do
No, wait a minute.
Right there. However, the You're welcome. Yeah.
That's gonna be a lot right there.